The UK uses about a fifth of the electricity it generates on lighting. Over its lifetime, a conventional light bulb will use the same amount of energy as there is in 3 metric tons of coal. There are great carbon savings to be made by developing more efficient lighting. Light-emitting diodes, or LEDs, are an energy-efficient way of producing light with only 10% of the carbon footprint of a conventional light bulb. Modern LED bulbs typically contain 4 to 6 chips, but cost 4 to 6 times more than traditional bulbs. To get costs down and be competitive, manufacturers require LED bulbs with just 1 chip. This requires significant increases in the efficiency of LED chips.
At the University of Bath, we're working in conjunction with the universities of Cambridge, Manchester and Strathclyde in an EPSRC funded project called Lighting the Future, which is aimed at solving fundamental problems that limit the efficiency of today's LEDs. We need to improve the quality of the material, so basically we just get more light out of each individual little chip.
Not all the light produced within an LED chip makes it out. By better engineering the materials that go into LEDs, more efficient light output can be achieved.
The material that's used in modern LEDs is called gallium nitride. It's a semiconductor that's emerged with technological importance over the last 15 years.
Researchers at the University of Bath are developing novel methods for improving LED efficiency. They are embedding tiny structures, known as nanostructures, into the LEDs.
Light-emitting diodes are made out of layers of different semiconductor material, all put together in the same chip. When you try and put them together, defects are generated. And these defects reduce the quality of the light.
Incorporating nanostructures into the LED chips encourages the semiconductor materials to grow in a much more regular crystal structure.
Fewer defects are created, which means that the light output is better, the efficiency is better, and there is less wasted light.
The nanostructures allow the researchers to have much more control over the direction of light produced by LEDs, allowing them to focus beams of light, which is of use in projectors or car headlights.
One thing we're trying to do is reduce the cost of making LEDs. There's no point in making the most perfect LED if no one can afford to buy it. At the moment, almost all LEDs are made on sapphire wafers, which are only 2 inches in diameter and also very expensive, and actually also in very limited supply. So we're now trying to develop processes in conjunction with partners in industry to make LEDs on silicon. Silicon's very cheap, it's also very widely available, and it's also a very well established technology, so the processing is very well developed.
The scientists at Bath are also working with industrial partners to improve the transfer of this new technology to the commercial sector, helping to give this research greater impact on society.
Our current EPSRC grant, Lighting the Future, we believe the outcomes of that will be more efficient LEDs that will help reduce our carbon emissions and also make LED lighting more cost effective for consumers. We see that not so much as an end, but as a beginning, as new lighting technologies, new ideas of how we can use lighting will also spring from this research.